Welcome back to my YouTube channel. Today, we're going to continue our good work. And we're going to start with logarithm, logarithmic expression or function or numbers. So, let's see how it's logarithm or logarithmic expression. We're going to look at what is logarithm, the relationship between exponential, the last topic, and logarithm. They are related. The relationship between natural logarithm and common logarithm. What we know at this level, I'm very sure, is common logarithm. Now let us see how to relate both of them. We look at some axioms, the properties, the rules, the regulations, the property of logarithm. This is very important. The law and the logarithm table. How to use logarithm table to solve problems. Instead of using calculator multiplication, we use logarithm table. Today, we're going to look at it. Let's begin. Good. So, let's say we have b to the power of a is equal to a. Now, this is exponential, right? This means the base. This means the power, right? And this is like the argument. And this is equality sign. Now, we can relate this guy or find the relationship with logarithm. What do? This base come to this side. So, we have log. This is short form of logarithm. Log b, the argument of a, is equal to x. What am I saying here? The base, this is the base. This is the argument, the real number, and this is the unknown number we are looking for. So, if this base go and carry this guy, the logarithm go. You can see the relationship between exponent and logarithm. When this leave, carry this guy, we have b to the power of x equal to a. That is the relationship between the exponential and the logarithm. I hope that's clear. So let's see some example on this. Let's say we have 2 to the power of 5. This is exponent. We know that 2 to the power of 5 means 2 times 2 times 2 times 2 times 2. Would give us 32, right? 2, 2, 4, 8, 16, 32. This is the exponent. If we want to write the corresponding logarithm, what do we write? Don't forget, this is the base. This is base. This is the index, or you say power. Or here is exponent, right? And this is the result. Now, writing is corresponding in logarithmic way. This is the base. It means we have the log of the base, which is 2. The argument, which is power, is equal to what? This guy carry this, so we have 2 carry 32, which is equal to 5. How do we know it's equal to 5? Let's see. This is what? Log 2. 32, it means 2 to the power of 5. This guy, the base and the number is the same. So they cancel each other, and we have what? 5. This is some laws, okay? We're going to look at this law very soon. This some laws. So this is, I'm trying to tell you how to write the exponential in logarithmic way. Okay? This is just an intro. Now let's go a little bit inside this theorem. Okay? Now, let's see the relationship between the common logarithm that we know and the natural logarithm. Common logarithm and natural. So let's say this is natural. Versus common log. First, let's work with common. The common logarithm is what we write here. If you say log in base 10, log in base 10 is common log, because base 10, you know, when you are counting numbers, counting, you get to 10, or you go to 9, before you can write any other numbers, it comes from the digits from 0 to 9, right? So the base 10, which is binary, is the common logarithm. So instead of me to write log in base 10, I can rewrite it as log. It means there is a 10. There is 10 here, it means it's common. So if I did not put anything in the base here, it means it's 10. Okay? For the natural, instead of writing log exponent is the same thing in the natural. So, which means you can write it also as log. Some people even write it as lim. I-N, lim. So, this guy is the same. It's natural, and this is the common. And exponent is what we use. Okay? So please take very good note of this. So if I say log x in base e, what do I mean? Instead of to write this, I can write it as this guy is equivalent to ln x. All these are very important when we get to the word of calculus. Okay? This is very calculus. These are very important. Okay? So instead of writing log base e x, I can write ln x. Natural. For this guy, I can write log, instead of writing log in base 10 x, I can just write log x. Log x. It means that the base here is 10. Take note. Common logarithm and natural. Natural use ln, common use base 10 without. Right. So take note. So if the base is not 10, I have to specify. Like this one now, base is 2, I must write it. If base is 2, I must 3, 4, 5 up to 9, I must write it. But if it is 10, I may not. I may. So if I do not write anything here, note that it's base 10. Okay? Good. Let's look at some rules. The axioms, the properties, the law of logarithm. The first law or rule is power rule. Power rule. That is, if you have log in base a, x to the power of w, this is the base, this is the argument, and this is the power, the index, the exponent. The rule says this exponent goes to the back of the logarithm. So we have w log in base b argument x. I will together. This is base. This is power. And this is argument. So this is very important. Okay? Now let's do an example. Let's say we have log 2, 3, power of 4. Log in base 2, 3 to the power of 4. What the law says? The 4 go to the back. So we have 4 log in base 2, 3. Finish. It's a rule. How these are very important. Let's have another example. Let's say we have ln 3 to the power of 7. Don't forget this ln is correspond to to log exponent e, right? Good. So the same rule is the power. Power must surely go to the back. So we have 7 ln 3. Finish. Okay, I think enough of this. Let's go to the second rule. Let's call this one rule 2. Identity. Identity. Your ID card. Something that identifies you, right? Something that shows that you are the one. So the way an ID card, you look at the picture and look at you if it's identity card, right? Good. The same thing here. If we have log of A in argument A, this is identity. This is identical. The number in the base is the same with the number in the argument. If it's the same, you say it's what? 1. 1. Because they are identical. Let's do an example. Let's say we have log 4. 4. Answer is what? 1. Right? Let's make it a little bit easy. Log 32 in base 2. First, you have to break this guy down. If you break it down, you have log 2 to the power of 5, right? Power says here, go to the back of logarithm. So we have 5 log 2. Now another rule comes in, right? Says that they are identical. The number in the base is the same number in the argument, and if it is the same, is what? 1. So 1 times 5 is what? 5. You see? This is very important. Let's apply it to natural logarithm. Let's say we have ln e to the power of 7. Ln e. Don't forget that ln, naturally, it means log in base e. That means I can write this as log in base e to the power of 7. This and this is the same. This is natural logarithm and this is common logarithm. Now, 7 is power. You go to the back, so I can say it's 7 log e. What do you notice? Base is e, argument is e, is what? 1. So I can say the result is 7. So from here I can say ln exponent is what? 1. Ln exponent is 1. And what is left is what? 7. Do you understand? This is the foundation to the world of calculus. Please take it very serious. Okay? Now let's move to the third rule. This rule, I call it 0 rule. 0 rule. Why I call it 0 rule? Log in base A 1 is 0. But you can ask me, how is 0? I don't want you to go and memorize it. Let me prove it for you. Remember, the law of exponents says anything to the power of 0 is what? 1. Do you remember? Good. If anything to the power of 0 is 1, so I can pick any number I want. If I like, this is A, I can choose A. If I like, I can choose B, I can choose C, I can choose W, I can choose Q, I can choose 1 million, I can choose 3 trillion. But power of 0. So anything power of 0 is 1. So I can say log in base A to the power of 0 is the same. Right? This guy is the same with this guy. So if it's the same, I can say power, according to this rule, power goes to the back. So I have is 0 log A in base A. So anything times 0 is what? Is 0. This is is zero. That's how we say that log in base A 1 is 0. I just use it to prove for you. You can move from here to this place. Do you understand? Let's observe. Let's say we have log in base 10. Okay, log in base 10. If I log base 10, it's natural. Common, I don't want to write it. Log 1. Log 1 is what? Is 0. What is here is 10, right? And do your proving, so you can say this is log 10, 10 power of 0, right? Which is what? Is 0. What of, if I have natural, ln 1. Ln 1 is also what? Is 0. Because we know that ln is the log exponent power of 0. If I do not write exponent, I can write W. Anything I put there is this. Give me 0. I can say 0 log E W. 0 times everything here is 0. So it's not compulsory. I must use the same. It's not compulsory. I can use anything here. Okay? Once it's power of 0, I will get it 0. So ln 1 is what? 0. Notice. Calculus, we are going to make it. We will make it. Let's go to the fourth rule. The fourth rule, let's call it product rule. Product rule. That is, we have log in base A x plus log in base A y. Now we have two log here. Log in base A, log in base A is common. Choose one. So we have log in base A. Addition become multiplication. So we have x times y. X times y. Let's do example. Let's say we have log in base 2, 8 plus log in base 2, 4. Following the rule, log in base 2 is common. I choose one. So I have log in base 2, 8 times 4. And 8 times 4 is what? 8 times 4 is 32. So I can express this just like what I have here. So I can write log 2. Let me write it here. So that I can divide this. Log 2 power of 5. Right? You understand how we get power of 5? Okay. I believe you understand. I did this here also. I believe you understand. You just use your 32, 2, 16, 2, 8, 2, 4, 2, 2, 1. 1, 2, 3, 4, 5. That's how you get this. Okay? So, what is the law says? The first law says power goes to the back. So, power here goes to the back. So I have 5 log 2. Another rule. The same number in the base and the argument. The same number in the base and the argument is what? 1. So this guy become 1. So 1 times 5 is 5. Let's do an example. Let's say we have now let's use natural. Ln 2 plus ln 3. Ln is common. I can choose one there. So I will have ln 2 times 3, which is ln 6. Right? Easy. This is very easy. Good. Now, fifth rule. Quotient. All these terms very important. Quotient rule or quotient law. If you have log in base C A minus log in base C B. Log in base C is common. Choose one. You have log in base C. Give subtraction becomes division. So we have A divided by B, which means log C A over B. Let's do an example quickly. Let's say we have log 2. Okay, let's say log 3, 162 minus log 3, 2. Log 3 is common. We choose one log 3. So we have log in base 3. The law says minus becomes division, so we have 162 divided by 2. And 162 divided by 2, this cancel this, that's 81. 81, we can express this this way. It will give us log 3, power of 4, right? Power of 4, power says go to the back, right? So we have 4 log 3. Anything in the same base and argument is what? 1. Now you should know it now. You should be dancing with it now. So if it's 1 times 4, answer is 4. And that is the final answer. Final answer is 4. Let's do one more example. Let's say we have lim, with our hand, lim 7 minus lim 3. Lim is common. We have lim 7 divided by 3. Simple, because you cannot divide this, right? So okay, let me combine this rule. Let's say we have log in base 2, 6 plus log in base 2, 3 minus log in base 2, 9. Now I try to combine log 4, log 5 together. You will see that all this law, everything we solve this. What have been doing we solve it. Let's start. Log in base 2, log in base 2, log in base 2 is common. Choose 1. So we have log in base 2. Addition becomes multiplication, so I can multiply 6 by 3. Divide by 9. And this gives us what? Log in base 2. I can cancel it. 3 goes here 1, 3 goes here 3. 3 goes here 1, 3 goes here 2. So what is left here is log in base 2, 2. One is a friend. Are we together? Let's go to the 6th. So let's move to the 6th rule. The 6th rule, I call it inverse property of log. And I will combine it with inverse property. Okay, let me just explain this one first. I will now explain the second one. If they work together. So if you have log, let's say base a power. Indirectly, we have explained this rule before, but we want to combine it. This guy comes to this place, right? So this is the same. We say is what? K. We explain this other power, but we do not explain that it's cancelled, right? Now, inverse property of the exponent. Now, instead of having logarithm down, we now have it up. So we have a log base a k. The k is there. This base is the same with this power. So if it's the same, the answer is also k. This is very important. We have to understand. Okay? This is very important. And then this can be proved using change of base. So I will use change of base to make this clear now. Let me call it rule 8. Change of base. Change of base says if you have log a in base b A in base B. Change of base means we have log B divided by log A. It's called change of base. You change this one logarithm to be 2. Log of the argument and log of the base. Okay? Now, how does this apply to prove this guy? How does it apply? Let us see. Don't forget that the log take the number, right? The log take the number. Let's apply it here. If you use change of base here, you have log A power of k divided by log A, right? And this you say is what? Power, go to the back according to power rule. We have k log A divided by log A. You see the f of this guy now. Log A cancel log A. What is left is what? K. You see, this guy is the f of change of base. Do you understand? And then you can apply the same thing in this place. What do you learn? If you remember the first rule, say the power, the base, go and carry this number. If this guy go and carry this number, you say it's what? Log A, K is what? K power of A power of K. Are you together? And from that, you can use the change of base and everything cancel. What am I saying? Let us try to write something out. Or let us solve some example. Let's solve some example to explain this. All this guy, the base on this guy. So let's say we have, and then let me say this before we go. Since I do not write anything here, it means what is base 10. Don't forget. Since I do not write anything, it means it's base 10. You can also log 16 in 32. Log in base 16. Of course, this can be anything. It can be base 1 million. So don't be panic. This kind of things, it is good to apply change of base because these are people. So if I apply change of base, we have log 32 divided by log 16. Since I don't have anything here, it is what? Base 10. Keep it. So if base 10, I may not write it. I know it's base 10. So break this guy down. We have log 2 power of 5 divided by break 16 down. It's what? Log 2 to the power of 4. Right? This guy come here, this guy come here. So we have 5 log 2 divided by 4 log 2. And that is what? 5 by 4. Or you said 1 whole number, 1 whole. Right? Very easy. Change of base is extremely very important. Okay? Any question? Good. Now let's check the logarithm table. How to use logarithm to solve.